Now, this video is all about the computation parts of calorimetry. Now, let me show my screen, share. Okay. Now, for calorimetry, we have a formula which is Q is equal to mCp or C delta T, which is equal to heat of reaction. So Q now is in heat. Okay. So heat is represented by variable Q. The unit for heat is joules, and we have a conversion for 1 calorie is equal to 4.184 joule. And M stands for mass in units of grams. Cp is the specific heat of a substance. Usually this is in joule per gram degree Celsius. Delta T is the change in the temperature, final temperature, or mixing temperature minus initial temperature. Heat capacity of the calorimeter is in terms of Ccal or capital letter C. So the unit for the heat capacity of calorimeter, Ccal, is in joule per gram degree Celsius. Now we have fixed value for the heat capacity of water or specific heat of our water, which is at 4.184 joule per gram degree Celsius. Now let's proceed with the first problem. A calorimeter is to be calibrated. 72.55 grams of water at 71.6 degrees Celsius added to a calorimeter containing 58.85 grams of water at 22.4 degrees Celsius. After stirring and waiting for the system to equilibrate, the final temperature reached at 47.3 degrees Celsius. Now we're going to calculate the heat capacity of the calorimeter. So how are you going to do that? Now let's provide our given. Now we are given with a calorimeter. The substance inside the calorimeter, and we have a calorimeter containing 58.85 grams of water. So inside the calorimeter, we have a cold water. It is the water inside the calorimeter before mixing. So the mass of the water inside the calorimeter, according to this problem, is at 58.85 grams. So this is represented as MCW, or the mass of the cold water, and the initial temperature of the cold water, according to the problem, okay, TC is at 22.4 degrees Celsius. And then the specific heat of the water is 4.184 joule per gram degree Celsius. Now, to perform the experiment, we have added it with a hot water. The hot water is at a mass of MHW, which is equal to 72.55 grams, and the temperature of the hotter water, TH, is at 71.6 degrees Celsius. The specific heat of water for cold and hot water is at 4.184 joule per gram degree Celsius. Now let's proceed. Now after mixing, and we have waited for the system to equilibrate, the water temperature is at 47.3 degrees Celsius. Now, this is already the final temperature for both mixtures. Okay. So we're going to use as 47.3 degrees Celsius for the mixing temperature or final temperature of both mixtures. Now, note, for calculating the heat capacity of the calorimeter, that the initial temperature inside the calorimeter is always the same as the initial temperature of the substance inside the calorimeter, which is the cold water. Now let's proceed with the calculation. So we are required to determine the heat capacity of the calorimeter. So we have two versions of solution. The first one is the long cut solution. So first, we need to calculate the heat lost by the hot water. So this is in terms of QHW, or the heat loss of the water, is equal to the absolute. Do not forget to put the absolute value. So the mass of the hot water multiplied with the heat capacity of the water multiplied with the mixing temperature, or TF, minus the initial temperature of the hot water. So Let's plug in the values. This gives us the absolute value of 72.55 grams of the hotter water multiplied with the heat capacity at 4.184 joule per gram degree Celsius. And let us multiply it with the change in temperature or the mix in temperature minus the initial temperature of the hot water. So this instance, it is 47.3 degrees Celsius, which was the mixing temperature minus the initial temperature, which is 71.6 degrees Celsius. This gives us 7,376.2456 joules for the heat loss of the hot water. Now let's calculate heat gained by the cold water. So this is the formula for the heat gain by the cold water. QCW is equal to the absolute value of, take note of this, we're going to use the mass of the colder water, multiply it with the specific heat, multiply it with the change in temperature as the mixing temperature minus the initial temperature TC for the cold water, which is at 22.4 degrees Celsius. Now let's plug in the values. The mass of the cold water, 58.85 grams, multiplied with specific heat, 4.184 joule per gram degree Celsius, multiplied with the change in temperature, 47.3 degrees Celsius minus 22.4 degrees Celsius. This gives us an answer of 6,131.0872 joules. Now, the third thing we're going to calculate is the heat gained by the calorimeter. Qcal is equal to, let's going to let's subtract QHW and QCW. So 7,376.2456 joule minus 6,131.0872 joules gives us the heat capacity or heat gained by the calorimeter at 1,245.1584 joules. And lastly, we're going to calculate the heat capacity of the calorimeter. So Ccal is equal to Qcal all over the change in temperature, Tf minus Tc. Let's plug in the values. Ccal now, or the heat capacity of the calorimeter, is equal to the amount we have subtracted earlier, which is 1,245.1584 joules per or divided with 47.3 degrees Celsius. This is our mixing temperature minus the initial temperature inside the calorimeter, which is the cold water, is at 22.4 degrees Celsius. This gives us with the answer of 50 joule per degree Celsius. Now, we have the second version of solution as shortcut. After mixing, the system had gained heat, which is the cold water and the calorimeter, while the system that lost heat is the hot water. Why? Because from higher temperature of the hotter water, which is at 71.6 degrees Celsius, when it was mixed with the cold water, it decreased its temperature at 47.3 degrees Celsius. Now we have the derivation of the formula, heat gain plus heat loss, which is equal to 0. If we're going to transpose heat loss to the other side of equation, this becomes negative Q loss. And then again, from the experiment, after mixing both substances, the systems that gained heat are the calorimeter and the cold water. Why? Because the calorimeter and the cold water, which was inside the calorimeter, the initial temperature of both is at 22.4 degrees Celsius. Once mixing it with the hot water, the calorimeter and cold water had a final temperature of 47.3 degrees Celsius. So from 22.4 degrees Celsius, it has increased to 47.3 degrees Celsius. So both systems are the systems that gained heat. Whereas the system that lost heat again is the hot water. Why? From 71.6 degrees Celsius, mixing it with cold water, the temperature became 47.3 degrees Celsius. Now let's expand the formula for the heat of calorimeter. This is equal to Ccal times the change in temperature, Tf minus Tc. Ccal stands for the specific heat of the calorimeter itself plus the specific heat of the water multiplied with the mass of the cold water times the change in temperature of the cold water. So mixing temperature minus the initial temperature of the water equal to negative of the mass of the hot water times the specific heat of the water times the change in temperature Tf minus Th. Now, if we're going to get Ccal, this equation becomes in this form. So how it did become like this? We have to transpose this following quantity MCWCpH2O Tf minus Tc to the other side of equation. So this becomes negative and divide both sides of equation with Tf minus Tc. Now, if we're going to plug in the values, this gives us the following: negative of 72.155 grams multiplied it with 4.184 joule or 4.184 joule per gram degree Celsius times the change in temperature 47.3 degrees Celsius minus 71.6 degrees Celsius. So this is the amount of heat for the cold water minus 58, hot water, minus 58.85 grams multiplied with 4.184 joule per gram degree Celsius times 47.3 minus 22.4 degrees Celsius. So this is the amount of heat for the cold water all over the change in temperature at 47.3 degrees Celsius minus 22.4 degrees Celsius. Now this gives us a value of 50.0064 joule per degree Celsius. Now our next video is the second problem for calculations of calorimetry experiment.